Right. Strap yourselves in, because today we are diving deep into something truly spectacular.
Oh, yeah.
NASA's Roman Space Telescope.
It's gonna be a good one.
And we know this thing is going to be amazing because it just hit a huge milestone.
Yeah.
All its instruments, its telescope, and the spacecraft.
The whole shebang.
They're all together now. All is one.
All one piece.
And this isn't just another space telescope.
Oh, no.
It's going to help us.
This is going to help us answer
Some of the biggest questions.
some of the biggest questions about the universe.
Like, what is dark energy?
Yeah.
Are there other planets out there like ours?
Exactly.
Big questions.
Well, what makes this integration so important is
Yeah.
it kicks off a really intense testing phase.
Okay.
You know, you can think about it like
Okay.
sending your meticulously built Lego masterpiece
Mhm.
through a wild obstacle course
Okay.
to make sure it can survive the journey.
Right.
They're going to simulate all sorts of harsh conditions,
Oh, wow.
intense vibrations.
Extreme temperatures of space.
Yeah.
Even electromagnetic interference.
So they're putting Roman through the ultimate space boot camp.
That's one way to put
That
it.
makes sense, though. I
Yeah.
mean,
You don't want to send all this
all this incredible technology up there,
millions and millions of miles away.
only to find out it can't handle the trip.
Exactly.
But
That's
what about once it gets there?
yeah.
What is Roman going to be doing?
millions of miles.
Millions of miles away from Earth.
This is where it gets really exciting.
Okay.
One of the biggest mysteries Roman will tackle
Okay.
is dark energy.
Okay.
Now, this is a force
Oh, right.
we know very little about,
Right.
but it's thought to be this weird, almost anti-gravity force
Okay.
that's making the universe expand at an accelerating rate.
Okay.
Imagine blowing up a balloon,
Mm-hmm.
but instead of slowing down as it gets bigger,
Right.
it just keeps expanding faster and faster,
So dark energy is
pushing everything apart. Pushing everything apart faster and faster.
faster. Yeah.
So how does Roman
Yeah.
help us understand this strange force?
Well, Roman is going to be making incredibly precise measurements of how galaxies are distributed
Uh-huh.
and how the universe has expanded over time.
Okay.
Think of it like creating a massive cosmic map,
I like it.
stretching billions of years into the past.
Oh, wow.
And by studying this map,
Right.
scientists hope to figure out
Okay.
what dark energy is and what its implications are for the ultimate fate of the universe.
It sounds like Roman is going to
Thanks, Steph.
rewrite the textbooks
Yeah,
on our understanding of the universe.
absolutely.
And we haven't even talked about the search for exoplanets
Oh, that's right.
with a field of view 100 times greater
100 times.
than Hubble's.
Wow.
What kind of
I mean,
planet hunting capabilities are we talking about here?
imagine instead of looking through a keyhole, you suddenly open a door to a vast panoramic vista.
Oh, wow.
That's what Roman's wide field instrument will do
All right.
for our view of the cosmos.
Hey, that's pretty amazing.
It's not just going to help us find more planets.
Okay.
It's also going to help us see them more clearly
Right.
and even study their atmospheres.
Oh, wow.
We might be able to detect
So
what kind of gases are present.
hold on. So we might actually get a glimpse
We might.
into what these distant worlds are like.
Yeah, we might be able to tell if a planet is potentially habitable.
What kind of information could we glean
Yeah.
from studying their atmospheres?
Think about it this way.
Okay.
If we detect oxygen
Uh-huh.
in the atmosphere of a planet that's within the habitable zone of its star,
Okay.
that would be a pretty good sign
Yeah.
that it could support life as we know it.
Right.
Or if we detect methane,
Okay.
which can be produced
Mhm.
by both biological and geological processes,
Right.
it would be a major clue that warrants further investigation.
Okay. Roman could essentially create
Wow.
a short list of the most promising candidates for future missions
Oh, that's pretty amazing.
to study in even more detail.
This is incredible. We're not just looking at dots
No.
on a star chart anymore.
No.
We're potentially peering into the atmospheres
Exactly.
of alien worlds.
It's incredible, isn't it?
Now, I know you mentioned the coronagraph.
Yes.
How does that technology actually work?
Okay, well, think of it like this.
Okay.
Trying to spot a firefly next to a giant spotlight.
Mm-hmm.
The spotlight's glare would completely overwhelm
Right.
the firefly's faint light.
Right.
That's what happens when we try to see planets orbiting distant stars.
Okay.
The star's light
Hmm.
completely washes out the planets.
Right.
The coronagraph is like a high-tech shade that blocks out
Oh, okay.
the star's light, allowing us to see.
So it's like a cosmic trick of the eye,
Exactly.
blocking out the bright star to reveal
The
hidden
free-
planets around it. You got it.
This technology sounds like
It's pretty neat.
it's going to be crucial for
Yeah.
achieving Roman's mission goals.
Absolutely.
It really does feel like
Mhm.
Roman's going to change the game
Oh, yeah,
when it comes to
for sure.
understanding exoplanets.
Absolutely.
But let's circle back to dark energy
Okay.
for a second.
Yeah.
If Roman does help us
Right.
solve this puzzle,
Yeah.
what are the potential implications?
The implications are huge.
Okay.
Our current understanding of physics relies on this delicate balance
Okay.
between gravity, which pulls things together,
Right.
and the expansion of the universe,
Ah.
which pushes things apart.
Okay.
But dark energy throws a wrench into all of that.
Oh, okay.
It's like adding a turbo booster
Okay.
to the universe's expansion.
So if we unlock the secrets of dark energy,
Yeah.
could it actually change our understanding of fundamental physics?
It's definitely possible. Einstein's theory of general relativity
Right.
has been incredibly successful at explaining gravity and the large-scale structure of the universe, but it doesn't account for dark energy.
Okay.
If we figure out what dark energy is,
Yeah.
we might need to modify general relativity
Wow.
or even come up with a whole new theory of gravity to explain it.
That's mind-blowing.
It is, isn't it?
And what about the ultimate fate of the universe?
Right.
Does understanding dark energy
Yeah.
give us any clues about what might happen billions of years from now?
Right now, the leading theory is that the universe will continue to expand forever,
Okay.
eventually becoming a cold, dark, and empty place.
Okay.
But if dark energy behaves differently than we expect,
Okay.
it could change everything.
What?
It could even lead to a big rip scenario.
Oh, wow.
Where the expansion accelerates so rapidly that it tears apart galaxies, stars, and even atoms.
Wow, a big rip.
Yeah.
Talk about a cosmic cliffhanger.
I know, right?
It really puts things in perspective,
It does.
doesn't it? All the more reason
Right.
to figure out this dark energy mystery.
Exactly. And that's why Roman is so important.
Yeah.
It has the potential to provide us with the data we need
Right.
to understand these fundamental questions about the nature of the universe.
And let's not forget that Roman will also be capturing
Oh, that's right.
those incredible panoramic views of the cosmos.
Yeah, absolutely.
And with much greater detail than Hubble, right?
Absolutely. Imagine taking Hubble's iconic deep field image, which revealed thousands of galaxies in a tiny patch of sky,
Yeah.
and expanding it to cover a much wider area.
Wow.
That's the kind of resolution and depth Roman will provide.
Okay.
We'll be able to study the evolution of galaxies,
Right.
the formation of stars and planets,
Yeah.
and maybe even uncover new phenomena we haven't even imagined yet.
So not only will we get answers
Right.
to some big questions,
Yeah.
but we'll also get to see the universe
Right.
in a way we never have before.
Exactly.
Wow.
And one of the things I'm most excited about is that Roman's data will be freely available to the public.
Okay.
Anyone with an internet connection
Okay.
will be able to download and explore these stunning images
That's fantastic.
and potentially making their own discoveries.
It's like giving everyone a front row seat
Exactly.
to the greatest show in the universe.
It really is.
It's amazing to think
I know.
about how many people,
Yeah.
especially kids,
Yeah,
this could inspire
absolutely.
to get into science and space exploration.
It's a testament to the power of open science
Yeah.
and the idea that everyone should have the opportunity to be awestruck by the wonders of the cosmos.
Speaking of being awestruck,
Yeah.
I can't help but think about the incredible legacy
Oh, yeah.
of Nancy Grace Roman,
She was incredible.
who this telescope is named after.
It's a fitting tribute.
She really paved the way
Oh, yeah.
for so many groundbreaking space telescopes,
She did.
didn't she?
As NASA's first chief of astronomy,
Right.
she was a tireless advocate for space-based astronomy. And her vision was instrumental in making missions like Hubble and now Roman a reality.
It's a fitting tribute that a telescope
Yeah.
with such potential
Right.
to transform our understanding of the universe
Yeah,
bears her name.
absolutely.
Okay, so we've talked about the big picture implications of what
Right.
Roman might discover.
Right.
But let's get into the nitty gritty
Oh,
for a minute. Can you tell us a bit more about the technology
Yeah.
that makes all of this possible?
Roman is equipped with state-of-the-art technology that pushes the boundaries of what's possible in space-based astronomy.
Okay.
Its primary mirror is the same size as Hubble's, which is already pretty impressive.
That's pretty big.
But it's the combination of this large mirror with Roman's wide field instrument and the advanced coronagraph that really sets it apart.
So it's like a super-powered Hubble.
You could say that.
What kind of differences can we expect in the images we'll see from Roman compared to what we're used to seeing from Hubble?
Think of it this way.
Okay.
Hubble gave us exquisitely detailed portraits of specific cosmic objects. Roman is going to give us those same stunning details, but on a much grander scale.
Right.
Imagine those breathtaking Hubble images, but instead of focusing on a single galaxy or nebula, Roman will capture vast cosmic landscapes.
Oh, wow.
Filled with countless galaxies. It's like the difference between a close-up portrait and a sweeping panoramic shot.
So we're not just talking about seeing more objects, but also seeing how they're all connected within the larger structure of the universe. That's incredible.
It really is.
It really highlights how Roman is building on Hubble's legacy.
Absolutely.
While pushing the boundaries even further.
And that's one of the most exciting aspects of science.
What's that?
Each new discovery builds upon the knowledge that came before it.
Right.
Leading us closer to a more complete understanding of the universe and our place within it.
It's amazing to think about how far we've come.
I know. It's incredible.
In our understanding of the cosmos.
Yeah.
And it seems like we're on the cusp.
It feels that way.
Of even more groundbreaking discoveries with Roman.
Absolutely.
It's going to be a few years until the launch in May 2027.
Yeah.
But the anticipation is building.
It certainly is an exciting time to be following space exploration.
For sure.
And what I find particularly intriguing about Roman is its potential to not only answer some of our biggest questions about the universe, but also raise new ones we haven't even thought of yet.
That's a great point.
Isn't it?
Every time we think we're getting closer to solving the cosmic puzzle, we uncover even more mysteries.
It's true.
But that's what keeps things interesting.
Right.
It's the constant pursuit of knowledge and the thrill of the unknown that drives scientific exploration.
Couldn't have said it better myself.
Who knows what unexpected discoveries
you never know
Roman might make along the way.
The history of science is full of serendipitous findings that have revolutionized our understanding of the world.
It's like every time we take a step forward in our understanding, the universe opens up a whole new vista of possibilities.
I love that.
It's enough to make your head spin.
I know.
But in the best way possible.
It certainly is a humbling and awe-inspiring experience to contemplate the vastness and complexity of the universe. And Roman is going to give us a front row seat.
I can't wait.
To some of the most incredible cosmic phenomena imaginable.
Well, I think it's safe to say that we're both pretty excited.
Oh, absolutely.
About the Roman Space Telescope.
For sure.
What it might reveal about the universe.
Absolutely.
Any final thoughts?
This raises an important question.
Okay.
If Roman helps us unlock the secrets of dark energy.
And reveals a universe teeming with exoplanets. How might that change our perspective on life, the universe, and everything?
That's a profound question.
Yeah.
And one that I think we'll be grappling with.
Oh, I agree.
For generations to come.
For sure.
It really speaks to the power of scientific exploration to not only expand our knowledge, but also challenge our fundamental understanding of our place in the cosmos.
It's a reminder that we're part of something much bigger than ourselves. And there's still so much out there to discover and understand.
Well said.
Thank you.
So, to all you listeners out there. Keep your eyes on the skies.
That's right.
Because Roman's mission is going to be epic.
Oh, yeah.
And in the meantime, if you want to learn more, be sure to check out NASA's website.
Good idea.
For the latest updates, images, and videos.
Yeah, it's a great resource.
You can even follow the mission's progress. As it gets closer to launch.
Definitely.
Trust me, you won't want to miss this.
It won't. Until next time, keep exploring.